This example is very similar to what we looked at when I was going over the symmetry rules. So I'm going to go through this quickly. If we reflect it over the x-axis, it's going to fall down here. The x value stays the same, but the y value becomes opposite. Reflecting it over the y-axis, here, same thing. The x value is now opposite, but the y value stays the same. And then finally, when you rotate it around the origin, we would end up here. Both the x and the y value become opposite. So have this visual in your mind when you are asked to find symmetry of a graph, and it will help you to remember that reflecting over x changes the y, reflecting over y changes the x, and then the origin changes both of them. So we're going to be testing for symmetry. We're going to be using those symmetry rules to see whether it has x-axis, y-axis, or origin symmetry, and then we'll again find the intercepts. So if it has x-axis symmetry, we can replace y with negative y, and it will simplify back to the same equation that we started with. In this case, negative y squared is the same as y squared. This is the equation we started with, so yes, it has x-axis symmetry. If it has y-axis symmetry, we can replace the x with negative x, and it will simplify back to the same equation. In this case, subtracting a negative is the same as adding. This is not the same equation, so it is not symmetric around the y-axis. And finally, the origins. We're going to put both of them together, substituting negative y and negative x. We get y squared plus x, which again is not the equation we started with, so we do not have symmetry around the origin. Finding the intercepts, again substituting 0 for x to find the y-intercept. So we get y squared equals 0. Taking the square root of that, there's only one square root of 0. So that is our y-intercept as well as our x-intercept. Just to double check, because this does have x-axis symmetry, we want to make sure that we're not missing any x-intercepts. So now we're going to substitute 0 for y to solve for x. But we get the same thing, x equals 0. So we only have one intercept in this case. So I'm going to plot our one intercept. We do know that it has x-axis symmetry, however this one point isn't real helpful, so we can set up a t-chart to try and find the other values. And I'm looking at this is a different equation that we started with. We'll graph the equation we started with, y squared minus x. That's a typo, sorry about that. All right, so we'll set up a t-chart. Choose a few values because I know the origin is on the graph. I'm actually going to choose y values because my y is squared, and I'll have to solve for x. I think it'll be a little easier. We already know what the value for 0 is, so let's just see what happens around the origin. If I put negative 2 in for y, we get 4 minus x equals 0, so x equals 4. If I put negative 1 in for y, I get 1 minus x equals 0, so we get x equals 1. I'm just adding x to both sides. So that is going to give me a few additional points to plot. When x is 4, y is both positive 2 and negative 2. When x is 1, y is both positive 1 and negative 1. Hopefully you recognize this relationship as a sideways parabola. So when x is 9, y is both positive 3 and negative 3. So again, this would not be a function. If you remember the vertical line test, this fails the vertical line test. Last example, we're going to take a look at an absolute value function. So to check for x-axis symmetry, we replace y with negative y. In this case, there's nothing that will simplify, so it is not equivalent to the equation we started with. For x-axis symmetry, for y-axis symmetry, we replace the x with a negative, and the absolute value of negative x is the same as the absolute value of positive x. So that does simplify, so we do have y-axis symmetry. And to check for the origin, we replace both of them, but we already saw what happened when we replaced y with negative y. The negative will simplify from the x, but not the y. Intercepts, substituting 0 for y to solve for the x-intercept. Subtracting 10 from both sides. Multiplying by -1. The absolute value of x is 10. So thinking about what x could be 10 when y was 0, or x could be -10. So this goes back to the fact that we know it has y-axis symmetry, and those x values are opposite. And our last intercept would be substituting 0 for x. -0 is still 0, plus 10 is 10. So we have a y-intercept of 10. Plotting those points. We can, and knowing that the absolute value function is of v, we can get a decent sketch of our graph without a t-table. And finally, your 2 you-try questions.